are going to get into quadratic equations. It's a lot of good stuff to do with quadratics. And I think you'll see that they carry over to a lot of different types of questions. Now, one of the things that is important to think about as it relates to quadratic equations is there's certain things they like to test on, and we're going to start with this right away. For example, they love difference of squares, right? So if you can, be in a place where, you know the difference of squares well, you're going to be in a spot where you're going to be able to answer a lot of these questions correctly. So that's what I want to jump into first here. All right, so first things first, just getting this doc open, and then we'll go from there. All right, so this first question is one I've actually done with you guys before, but it incorporates a couple different types of skills here. One of them being quadratics, and then the other one being a little bit of number properties. So as always, I'm going to give you guys a couple minutes, work through this, and then we'll go from there. All right, take a stab at this, and we'll talk about it. All right, I see some answers coming in. Now, let me ask you guys a question. Did you guys immediately think about prime factorization the moment that you saw what we have here on the right? So when you're talking about this here, were you thinking about prime factorization? let's see. Yeah, exactly. So, and yeah, the question is, how do you convert it, right? Because these become pretty big numbers. So what you do is you utilize the difference of squares here. So 5 factorial minus 4 factorial times 5 factorial plus 4 factorial. That's the essence of the difference of squares there. So what we're talking about is, and then doing that out, 120 minus 4 factorial is 24, and then 120 plus 24, right? So when you subtract 24 from 120, you get 96. 120 plus 24, you're going to get 144, right? And then you kind of just keep going from there. Now you break it down, 12 and 12, 2 and 48, 6 and 8, and of course 8 is going to be 2 to the 3, so then 2 and then 3 for the 6, and yeah, from there you're pretty much good to go. So you count them up. 12 obviously is 2 to the 2 times 3, 2 to the 2 times 3. Count them up, and then yeah, you're off to the races. And that's how you end up getting 12 here. Now you may say, well, wait, what about the 13? Well, here's the good news. 13 to the 0, that's 1, so there's 0 13s. So that's why C would end up being 0. So A plus B plus C, you end up getting 12. These questions are from the Quadratic Equations mission. I don't know the exact number, but they're from the Quadratic Equations mission. All right, so that's not so bad. Let's keep going here. As I said, we're going to do a bunch of stuff with difference of squares. Give you guys this here next, and we'll go from there. Okay, sounds good. Let's start this here. All right. So again, everyone's recognizing difference of squares here without too much of an issue. I mean, I know you know we're doing it, so clearly that's part of it as well. But when you look at this, I think, you know, do you see that even though this is a 3 to the 8, this is 2 to the 6, did anyone have any issues saying, okay, this is the difference of two squares? I'm hoping that you're not just making it seem as though difference of squares only works when something's raised to a second power. So yeah, that's one of my big questions here, is whether or not you guys saw that this was 100% difference of squares, meaning, you know, can I break this into, you know, 2 to the 3, 3 to the 4 times 2 to the 3, 3 to the 4 plus 2 to the 3. I wouldn't use, I know what you're asking. I technically wouldn't use, I wouldn't use unit digit patterns here. I would use difference of squares. Yeah, I probably wouldn't touch unit digit patterns. Because, yeah, I just wouldn't, I would stay away from unit digit patterns. But the thing is, in a problem like this, like, you'll see difference of squares is so clean. That's the other thing. Because the problem is, like, unit digit pattern doesn't tell you if something's divisible by 73 or not. That's the issue, or some other number for that matter. So, yeah, that's kind of the way that I would think about that. So here we have 3 to the 4 times 2 to the 3, excuse me, plus 2 to the 3, or minus 2 to the 3 rather. So you're talking about, and you're going to see some of these like working out exactly how you would expect them to. Like, check it out. You can see very quickly and cleanly that, you know, 73 and 89 can't be answers, right? I mean, everyone agrees with that. And then you know you're kind of on the right track here. That's the other component of this. You know what I mean? And to me, that's, you know, that's really nice. So, yeah, that's the way that I would probably deal with this here. And then, you know, it's a matter of, okay, what do I do with the 63 and the 65, right? So there's some obvious ones. 9's clearly going to divide into 63. So now it really boils down to, what do you do with the 15 and the 11? Now, a lot of people say, wait, the answer could be 15 because 15 doesn't divide into 65 or 63. That's not how products work, right? The way products work is you're in a situation where this breaks into primes, 9 and 7, well, or just factors for that matter, 9 and 7, and then you've got 13 and 5, right? And you can see, oh, wait, 15 does work because 15 has a prime of 5 and a prime of 3. There's your prime of 5 covered. There's your prime of 3 covered, and then you're pretty much good to go there. So, yeah, so that means that 15, and then it leaves us with 11. So process of elimination works well. In fact, we can do one more similar one like this and then do a couple other things. But sometimes you don't have to go through all of the answer choices to come up with the right answer. All right, so take a stab at this here. All right, so did you guys follow the same process here pretty much? All right, perfect. Yeah, to me, that's the move. It's, it's very clean. Again, unit digit patterns, or excuse me, difference of squares is the move. It's super clean here. So we've got, 3 to the 5 minus 2 to the 5 times 3 to the 5 plus 2 to the 5. And same deal, you're going to get some obvious answer choices here, right? So 3 to the 5 is going to give us 243, right? 2 to the 5 is going to give us, or excuse me, we got to add those or subtract them. 243 minus 32. And that's what I mean by obvious answer choices. That becomes 211. And then 3 to the 5 again is 243 plus 2 to the 5, which is 32, is going to give us 275. So right off the bat, you eliminate. Now, for those of you who said that the answer here is D, how did you guys get that? How were you able to eliminate answer choice C? Any thoughts there? Well, yeah, if you know that, of course, yes. If you can tell that that's a multiple of 11, you're good. Another way to look at this is, 275 is not going to be a multiple of 3. 2 plus 7 plus 5 is equal to 14, right? And that's not a multiple of 3. So if 275 is not a multiple of 3, it's not going to be a multiple of 75. So that's another way you can kind of look at it. But yeah, what you guys said also works really nicely. All right, cool. Well, there is one I want to do that does involve unit digit patterns and difference of squares, and that's going to be this one here. Take a look at this, and then we'll chat about it. All right, besides me saying it, did you guys notice that unit digit patterns was probably going to be a maneuver here to deal with this question, and there's a reason for it. And that main reason is because the numbers are pretty huge. So anytime you see these big numbers, you guys agree that you're probably going to have to use unit digit patterns in some way? Yeah, exactly. They're not interested in you being able to calculate these large numbers. It's just not something that they do. So yeah, so instead, but you also, this is kind of incorporated with difference of squares as well, right? Because you see it's here. So anytime you see it, you want to use it. 3 to the 15 minus 2 to the 15, 3 to the 15 plus 2 to the 15 over 3 to the 15 minus 2 to the 15. These cancel, and then you're left with 3 to the 15 plus 2 to the 15. Now, that's when we go into our mode of unit digit patterns. So 3, 9, 7, 1. It anchors on the 1. So for example, 3 to the 16, because it's a multiple of 4 is a 1. 3 to the 15 is a 7. And then with the 2, 2, 4, 8, 6, it anchors on the 6. It repeats every 4. So 2 to the 16, multiple of 4 is going to be a 6. 2 to the 15 is going to be an 8, 7 plus 8. There you go. It's got to end in a 5, so it's A. So any questions about that? All right, so if you guys are good with that, this could be a good place to pause here and see if you guys have any questions. Questions about your GMAT, questions about TTP, really anything here. All right, anything at all, anything on your mind? No, the update is just moving some things around in verbal and then adding a whole new strategy section. We kind of broke up strategy in a different way, added some new lessons within strategy. So yeah, nothing crazy, nothing crazy, but just stuff that'll certainly be helpful for for you to read through for sure. So you'll see it. It's most of the content stuff is the same. The biggest change was definitely with strategy. Any other questions? Yes, what's that? All right. Well, if you guys have nothing else, then I guess we're good. No other questions? We'll see. Oh, here we go. If I do really well in verbal, like 90, even on the hardest, okay, well, that's good. That means you're doing good in verbal. Yeah, I think you could do maybe like a 4-to-1 ratio, 5-to-1 ratio. Don't forget about verbal altogether. But yeah, I'd say more or less you can do that. Probably next Friday should be the next one. So you'll get a notice when we do it. So, all right. Well, good stuff, everybody. Thanks for coming as always. And, we'll talk soon. And have a good, safe, healthy week. Reach out to us if you need us, okay? Talk to everyone soon.